Namaskar, welcome back. So in previous lecture we stopped somewhere here and we were talking about the how we can classify the terraces. Okay. So as I told that the terraces are erosional features, whether it is depositional terrace or erosional terrace, then how we can classify it. So erosional terraces are those which are having which shows incision in the bedrocks, whereas the depositional terraces where the incision is in the its previously deposited sediments. Okay. So mostly we see a sort of a step here. Suppose we are having a bedrock and then on top we are having alluvium. So this was the base of the channel where it flowed earlier. Okay. And this portion is the deposition portion or the deposition deposits which were deposited by the channel. And then later on, because of the change in the base level, this portion was been incised. Okay. So this is an incision, and this portion what we call is an deposition. Now as per the classification, if we see, then it has incised the alluvium as well as the bedrock. Both have been incised. Okay. So such type of terraces we will call as an erosional terrace. Okay. Or we can say strat terrace. And we have the scarp, or we can say that this scarp is basically the erosional scarp. Okay. It's nothing to do with the tectonics. Okay. And channel is flowing over here. Okay. So this is an erosional scarp we see. Now let us see how we will classify the erosional terrace or depositional terrace. Depositional terrace are also termed as aggradational terraces. So in this, what we have is that there is a valley boundary. Okay. So or the boundary of the channel is there. So you have this is a boundary of the channel. So this is the boundary here, and then once it get filled up, okay. So the first fill 1, okay, that means that it was filled till the top, okay, over here. So this goes, and this was filled up to this one. Then there was incision. So this is the process of incision which resulted into the formation of this terrace. Then again there was an fill, the next phase which came up to this, and further incision, then third one. Okay. So the third fill, and then again this fill has been. So you have 3 sets of terraces here. So if we demarcate this, then we have T0 here, this is T1 and this is T2. These are all aggradational terraces because they have incised their own valley fill deposits. Okay. So this part you can keep in mind. So we can also call this as an depositional terraces. So where we see the incision of its own deposits. Okay. Or we can say valley fill. Now coming to the degradational terrace, and this is your we say erosional. So erosional terrace, as we discussed here about that, it incises its own deposits here. They are incising alluvium or alluvium plus we can say your bedrock, and these are also termed as strat terraces. So this is the difference between the gradational terrace or depositional terrace and degradational terrace and or your erosional terrace. Okay. And as I discussed in the previous one, that is, since you are having this existence of this terraces or the erosional scarp on either side of the channel. So you have one step here, then there's a second step here, then third one is here. Similarly, you have one over here, then second, third, so on. Okay. So you have the T0 here, okay, and then you have T2, sorry, T1, and this is T1, and this one is T2. So these are termed as paired terraces. In case of unpaired terraces, you will not be able to observe the same elevated erosional scarp on either side of that. Okay. So you don't have the same terraces on the either side. So and mostly if the terraces are formed because of tectonic, not always, but sometimes we come across that the paired terraces are clear indicator of tectonic activity. Now, in the last figure, if you see, you can identify the strat terraces, okay, where you have this one is the bedrock. So this where it has incised here, including the alluvium, then this we will term this as an strat terrace. Whereas the another one is the gradational terrace, where the incision is gained by of its own deposit here. So this will be your gradational terrace. Okay. Now there is a degradational terrace in between here, which has been marked because this terrace, we can say that this portion is an gradational one because this was formed after the gradation of this face. Okay, but later this has been incised. Okay, so this is the only terrace which we can say is an gradational, whereas the other two are not gradational terraces, they are degradational terrace. So this one is your degradational terrace, this one is degradational terrace, again this one is a degradational terrace. Okay, only this portion is your gradational terrace, even though they have inside its own deposits, but there was not a process which got completed is your this cut and fill process. Okay, so for example, if you say that this was the channel, okay, and then the next phase was the fill phase. Okay, so there was a fill phase here, then when it incises, okay, for example, it incised like this. Okay, then this becomes a sort of your gradational terrace. Okay. But if it incises further here, then this becomes degradational terrace. And that is what has been shown here. So this portion was been filled up, okay, and then incision took place. So this was a gradational terrace. But further incision, this one here is your degradational terrace. So if you see this photograph, this is of Bias River, where we see the terraces. So this is a flat surface here, so flat surface, and then you have a lot of an escarpment. So this is the present day channel here. So this is a terrace, okay. And then another one, if you see here, there is one here which goes down, then further goes down, and then here. Okay, so this is your younger terrace. Okay, so if we can say this is T0, this is T1 here, or T1. So this is T1 here. Okay, and then further down also one we observed was this is T0. So this will become T1 because this is slightly higher, or maybe this is T0 same. Okay, so this is T0, and further up you have the T1. Okay, but this is T2 again. Okay, this was been marked as the higher or medial terrace. Okay, so this is much higher because if you see the elevation here, and that's what has been marked. Okay, so we see carefully here this one. So we have slight elevation over here also. Okay, and then goes down. So this is T1, and then this is T1, equivalent to this one on the either bank, and this is the higher terrace as compared to that. Okay, so this is T2. So here you can see the strat, or not strat, but the thread. Okay, so you have one going down here, then flat, and then going down, and then finally getting into the channel. There may be one over here actually. Okay. So depositional terrace, cut and fill, the process. Okay, the bedrock and alluvium has been seen. Okay, here this part, if there was a terrace which was been formed, then we could have called this as an strat terrace. Okay, but there is completely erode. So this will be in depositional terrace. Strat terrace, as I told, that you have a bedrock, and then so incision in the alluvium as well as the bedrock is your strat terrace or erosional terrace. Okay. So you have alluvium here, and lateral migration, as I have shown in one of the slide where we were looking at the cross section. So we see a sort of a migration of lateral migration of the channel in this side. Okay, and this is typical of meander channels. Okay, so you will have the greater depth here, higher velocity. This bank will be erosive bank, and this will be a depositional bank. So this is from again the sub-Himalayas, one of the river which is crossing. So at the base, what you see is the bedrock. Okay, so this is your bedrock, shivalics, and on top of that, which clearly you can demarcate the contact. Okay, or you can see the angular unconformity. Okay, you have here, and this is your alluvium. So this we will classify as an erosional terrace or strat terrace. Okay, so this will be your erosional or strat terrace. Another example of the strat terrace where we have, so this is your, like we were studying this from Punjab Himalaya. So this side we have the Indo-Gangetic plain. Okay, and this is shivalics, this side. Or sub-Himalaya, we can say the frontal Himalayas. And the fault which goes from here in this area, and this is a part of the active fault. And if you carefully look at the flat portion, okay, similar to what we are able to see the tonal variations in the Indo-Gangetic plain side. So this portion and this portion looks very similar. But this area is like this is the flat surface, and this surface is this one over here. So the photograph has been taken from this side viewing, and what we see is that there is an escarpment here. So this is the frontal part, and you see a sort of an uplifted portion of that. Okay. So if we see from the side, then what we see is the upper shivalics, and the on the top is your alluvium. Okay. So this is typical of the strat terrace. So this is a sketch of that, and we have been able to mark the paired terraces here. Okay, so you see this is exactly the portion what I was showing here, and at the base, this is what we have is here the T0. Okay, so this is your T0, and this is T1 or T2, T1 or T2, you can, whatever you, the nomenclature you can mark. Okay. So, this is a younger terrace and this is the older terrace. And the arrows which are shown here or marked here is marking your Himalayan frontal thrust. Okay. It is the seismically most active, okay, seismically active region on this planet, and also marks the tectonic boundary between the Indian plate and the Eurasian plate. Further, another example from on the way, if you go to Nainital, then you see an incision of more than 50 meters and one of the tributary of Gola River, and on top you see a sort of an alluvium here. Okay, so this is an alluvium which is sitting on the top. Okay, so again this surface, that means the channel flowed at this level in during the geological time scale. Okay, or the geological period we can say. Close up of that, so you have on bedrock, you have on top of that. So even at the younger terraces, we see a clear cut strat terraces. Okay. So you have a bedrock here, okay, and then you have alluvium on the top. So these are typical of strat terraces, could be related to tectonic activities, okay, in the region. Now, what we do is that we generate anaglyphs. Okay, we use high resolution cartosat data, which is a product of our country, that is from NRSC. You can buy, and that you can generate anaglyphs. So based on this, you can view the terrain in 3 dimension on your screens. Okay, so probably one lab part we will do. We'll try to organize one small lab where you can learn how to generate the anaglyphs. Okay, so this is a 2D image, and in you need to have two images of the same area. Okay, and this is a typical way of one of the robust methodology which we use in photogrammetry. So the 2 photographs have been taken. For example, if you have a flight here, and then you have 2 cameras which have been facing like this. Okay, and then you are recording the data on the terrain. Okay, so one is this here, like you're having the forward and after. So you can take the photographs of the same area by 2 different cameras. Okay, and that can be overlapped. Okay, and the overlap should be around like 40 to 50 percent of overlap, and that isn't typical of even in the, like if you fly like this and then come back, then there has to be an overlap over here also. Okay, on sideways. Okay, so you have overlap of this. So this overlap will help you in viewing the terrain in 3 dimensions. So generation of anaglyphs we will teach you in one of the lecture, and so this is the anaglyph of that. So if you use the 3D glasses, that is what we call the filter glasses of different colors, maybe it is red and blue or red and cyan color, so that will help you in viewing this terrain in 3 dimension. Now, what was the purpose of using this type of methods or the techniques? One was that uh, the most important is that you have to differentiate between the landforms. Okay, you have to build the stratigraphy of the landforms, which are older, which are younger, for example, which are at the elevated height, which are at the lower height, and all that. So you demarcate that, and if those surfaces are been displaced or cut by your faults, so that you need to pick up. Okay, and that can be done only if you have good view of the terrain in 3 dimension. because in 2D image, though it is very high resolution, you won't be able to differentiate between the uplifted areas or terraces and all that. Okay, to some extent you may be able to mark the terraces, but not at the accuracy which you can do with the anaglyphs. Okay. Now again, coming back to uh, the stream erosion and all that, this is again a very basic part that the channel will be like get affected because of the bed load, discharge and all that. Okay, and even the slope. Okay, so bed load can be because of the the changes you are having, the resisting power and all that, and this stream slopes also will affect the your discharge. Okay, now if they are triggered by the tectonic activities, then how and or non-tectonic activities, how we can differentiate. Okay, so factors controlling gradation and degradation process. Okay, so few points we have discussed in the previous lecture also. Okay, so factors that are controlling the deposition and erosional processes, it is well established that change in stream power affects the fluvial processes. Either the river will aggrade or degrade. That means it will start depositing or it will start incising, okay, eroding the areas. Okay. Now, along with the stream power, other factors. So, stream power can affect your process of aggradation and degradation, but along with that, sediment load, stream capacity to carry the sediments, roughness of the bed, okay, of the river bed also influences the gradation and degradation process. So, stream power, stream bed load, and you are having stream capacity and roughness. This will also affect along with the stream power. Okay. If river neither aggrade nor degrade, so it is not doing anything. Okay, so it is considered to be in equilibrium. Okay, equilibrium state, because it has nothing to do. But if you suppose you increase the slope, so increase in slope of the river plus increase in discharge plus decrease in river bed roughness. Okay, so slope has been increased plus discharge is also increased, whereas the river bed roughness is decreased, and decrease in sediment load will result the river to erode. So that means it has less resistance, discharge is more, but sediment bed load is not there that much. Slope is also increased, because slope, if you increase the slope, discharge will also increase, velocity increases. That will result the river to erode. Whereas decrease in slope plus decrease in discharge plus increase in river bed roughness, increase in sediment load, okay, and this will deposit. So you will have a gradational phase in the river. Now this can be also affected by your tectonic activity. So with this, we stop here, and we'll continue with more landforms in next lecture. Thank you so much. Namaskar.